Welcome to the cloudonaut podcast. We are your hosts, Andreas and
Michael Wittig. We have been building on AWS since 2009. Follow along as we build two products for the AWS Marketplace, bucketAV and marbot. This is episode number 79 and we are recording this on July the 20th in 2023. In case you're watching this live on YouTube or LinkedIn, feel free to send us your questions directly in the chat and we will answer them during the show. So in this podcast, we kind of share what we learned while building the products that I mentioned at the beginning. And this time I learned something new about SQS. So let me tell you a little bit about this. So SQS is a messaging service on AWS. So you basically get a very simple message queue. And what you can do is you can have then workers that work on the jobs in the queue. So this could be EC2 instances. It can also be ECS containers or Lambda functions. So in my case, it's EC2 instances because this is what our product bucketAV does. So when you upload a file to your S3 bucket, we basically send a message into a queue that says, okay, please scan this file for malware. And then we have EC2 instances that run, pick up those jobs and download the files and do the scanning. And what you can do based on the number of messages in the queue is you can scale the number of EC2 instances that are working on the jobs. And that's what we are doing. And I noticed one thing, or actually a customer noticed it, that when there are no messages in the queue and then out of a kind of like maybe because it's morning and the first message arrives, it takes very long for the first kind of spike to spin up the first EC2 instances. This even gets more of a problem if you scale down to 0 EC2 instances. So for example, some of our customers, they decide if there's nothing in the queue and then they just shut down all the workers. So the first message in the queue should then kick off kind of the first instance. But it is very slow for the first message. And the reason for that, what I learned is that in CloudWatch, there's this term of an active and an inactive queue. And the metrics to CloudWatch are only published for active queues. And one of the metrics that we use is the approximate number of messages visible. So that's kind of the default metric that most people use for scaling. So if the queue gets inactive because for 6 hours, no activity happened on the queue, then this metric is not published anymore. And then the problem is that it takes up to 15 minutes until this queue gets back into active mode when the first message arrives. And this then causes this long delay because we only look at this metric, and if the metric is not if there's no like value greater than 1, we don't scale up, and then like the message sits there for 50 minutes just because of that. So I looked into this, and this is documented, so I found it in documentation, but it's still not very satisfying. So what I did then is I realized that there are other metrics that are published more quickly, even if it's an inactive queue that gets activated. And one of those messages is the number of messages sent. And there's also my number of messages received, deleted, I think it's called. And this is kind of more or less the same value of same information than the number of messages visible. There's some problems with retries, but it still helps me to kick off the scaling quicker because the number of messages sent metric is just available within a couple of seconds after I publish the first message after 6 hours of doing nothing with the queue. So basically what we do now is instead of just looking at the approximate number of messages visible, we also take into account using metric math the number of messages sent as well as number of messages deleted to kind of solve this problem a little bit at least. I mean, it's not perfect, but it's better than waiting for 50 minutes. So yeah, that's what I learned. Inactive and active queues exist in SQS.
That's really crazy, Michael, because I always thought scaling a fleet of EC2 instances is the simplest when having an SQS queue in front of it, because there is this metric. And as always, if you really dive into the details and use something at a high scale and allowed with many customers, then you notice the issues around that. So yeah, thanks for sharing that. I think that's definitely something you have to watch out for when scaling a fleet behind an SQS queue, which is a great pattern, I would say, but be aware of that and maybe use the workaround that you described. Yeah, that's really, really interesting, Michael. So I do have, I've learned about some aspects of AWS in the past weeks as well, and I want to follow up basically on what I have said and written about AppRunner. So AppRunner is kind of a new service to run containers on AWS. And I've been quite excited about the new service because it is really easy to get started to spin up a web service based on a container image with the help of AppRunner. It's basically just one command in the command line to create everything you need. You don't have to know about load balancers, security groups, scaling configuration, and so on. It's a really easy to use service that encapsulates a lot of the complexity that you have. For example, even if you go with ECS and Fargate, you have still spin up a lot of resources, and AppRunner is much more a simplified solution. It has some other benefits, for example, the pricing model, because it can scale at least the CPU consumption to 0. Over the past few months, AWS has announced new features, and it seems like they are really actively working on AppRunner, which I find kind of cool to have a compute service somewhere in the middle between Fargate and Lambda, I would say. So it's still a running container, but they pause it. So it's kind of something in between, I'd say. And so I wanted to make use of AppRunner in a more enterprisey environment for one of our consulting clients. And to do that, I wanted to make use of the new features. So at the beginning, AppRunner was just a service that spun up your web application as a public-facing web application reachable over the internet. And you didn't even had the possibility to connect to VPC resources like a database or something at the beginning. But over time, AWS released both network ingress for internal applications from your VPC and VPC egress. So you can also reach, I don't know, the RDS database in your VPC or something like that. And of course, in an enterprise environment, I had to integrate or activate those two integrations, so for ingress and egress traffic to the VPC. And I've been doing that. And I was running into one issue with the VPC ingress feature of AppRunner. Because one of the features of AppRunner, and I like that, is that it automatically provisions the TLS for you. So if you configure a custom domain for your AppRunner service, you define the custom domain name, and then AppRunner will automatically create a certificate, validate the certificate in the background. But to make that happen, you have to use a custom, public domain name. So the DNS server, the DNS has to basically be able to resolve records for this domain. And in enterprise environment, at least I've know that from many of our clients. Many times they have internal domain names that do not resolve from the outside, from the public name servers, but only resolve on their own domain server systems. And so the issue with AppRunner is you can enable this VPC ingress to make it reachable from your VPC, and it also works over direct connect and everything. That's great, but you cannot configure a custom domain name for a private domain that is not resolvable from the outside. And that was a bummer. So basically, this was a showstopper in the scenario that I've been wanted to use AppRunner in. So yeah, this is missing and maybe interesting for someone else who runs into that. Basically, the only thing you can do is you can use, so AppRunner creates its own domain name with a subdomain, something dot, I think it's dot AppRunner.com or something. This works, and you can have a VPC endpoint for that, and you can reach that. Basically, it just resolves the public then, but you can't use it with custom domains. This is frustrating. So one limitation I was not aware of. And I've opened the ticket, and there's already a feature request for that, but who knows when this will change. So yeah, currently you have that limitation. So be careful when wanting to use the app runner in a more complex network or enterprise scenario. And the other thing that someone wrote me over LinkedIn, and I didn't know about that because so it's written down in the documentation, but it's not very prominent. As always, the important stuff is hidden somewhere. So there is a timeout limit for HTTP requests to app runner services. And this is, it has been raised a couple of times over time, but currently it is 120 seconds. So the timeout for each HTTP service is 2 minutes. That's something you have to have and cannot change that. So if you have a workload that requires HTTP request, this is a showstopper as well for app runner. So yeah, so those are 2 limitations about app runner that we need to be aware of, and I haven't been so far.
Okay, Andreas, that's interesting. Thanks for the update here. The next thing I want to talk about is that we actually, Andreas, released a new product. And it builds on the foundations of bucketAV. So this is the Amazon S3 antivirus solution offer, and it basically uses the same technology, but the files are not coming from S3. This time they're coming from Confluence or from Jira. And what also changed is that we are not selling this through the AWS Marketplace, but we are selling it through the Atlassian Marketplace. So we will see how this kind of compares. So they also have a kind of process, kind of approval process that works very similar to what AWS does. So they test your app. They have certain guidelines that you should follow to get it through the Marketplace approval process. And this worked for us. It took around a week. So this is kind of what they promised. And it was kind of without any like big issues. They found a couple of small things that we fixed, and then the app was available in the marketplace, or is available in the marketplace. The way it works from a technical perspective is that what we kind of did for bucketAV, and this is also a feature that we are going to release soon for all our customers, is that we added the capabilities for an API. So you can basically, with the next release of bucketAV, create an HTTPS API or like deploy an HTTPS API, and you can then send scan jobs to that API. And it is an asynchronous API. So the way it works is you send an HTTPS post request to it. And this post request contains, for example, the information about the file you want to scan. And you also include what we call the callback URL. And this URL will be invoked by bucketAV with the scan result. So as soon as the scan finishes, we make an HTTP post request to your callback URL. And that's how you get the information back. So that's kind of how it works. We are not yet offering a synchronous API where you kind of send the file and get the result back directly, because we don't think it's a very good fit. Had many limitations if there are large files that take an hour to scan or so. You really have to keep the HTTP connection open for an hour. I don't think that's a good idea. But yeah, that's what we have. The capabilities will be included in the next bucketAV release. So that's actually kind of, yeah, our existing product bucketAV kind of benefits from that. And we also kind of open up our possibilities to kind of integrate into other platforms later as well. So that's it. One thing that I learned, Andreas, and this is not really technical, but it's more from a developer experience kind of viewpoint. Creating an app on the Atlassian platform is really straightforward. So they call it a fork app, and basically you install a little command line tool on your machine. And then in, for example, development mode, you just type in fork tunnel, and then kind of you see the events that are coming in, and they are executed using your source code. When you change something on your laptop, it immediately is deployed. And the next time an event comes in, the new code is executed. So this is really cool, and I was really surprised and in a positive way by this. It's really simple to get started and simple to develop something there on their platform. It was really a pleasure working with it. And then, for example, yesterday I just ported everything working, and then, for example, took Confluence to Jira. So it took me 1 day. And this is really, I mean, that's amazing. So you can create a new app if you are familiar with everything in a day. So it took me 5 days for the first version to get done, including a website and all the marketing stuff. And this time it just took 1 day. And this is really cool. You don't have to spend much time with stuff that doesn't matter here. So
it sounds really like a great developer experience to have everything on your machine, be able to test things quickly. So imagine that would be the same with the AWS Marketplace and everything. Oh, wow. Okay, Michael. So I'm looking forward to the results. So how attachmentAV performs in the market. So looking forward to that. A complete other thing, Michael. So I have learned something about Terraform. So so I'm currently working on a project where we have where we use Terraform modules heavily together with TerraGrunt. So we use TerraGrunt to basically combine all those modules that we write. And we also use open source modules, for example, the very popular Terraform AWS VPC module. And as you know, with the one thing with Terraform is that you constantly have to update all the versions. So you have to update the Terraform modules that you're using. You have to update Terraform itself. You have to update the AWS provider that comes with Terraform. And you have to make sure that all those versions work together and make sure you stay up to date, because if you don't do that, I've learned that the hard way, you end up in a situation where it's very hard to get everything up and running. So I'm constantly making sure that everything is running on one of the latest versions. And I learned something that I was not aware about. So when you when you create a Terraform module, or it also applies to Terraform configuration, and you import or configure a provider like the AWS provider, for example, then you specify the provider version that you want to use. So say, I want to have AWS provider, and I want to have a version greater or equal than, I don't know, 5.0 or 4.0, whatever you prefer. And the problem that I have been running into is that, of course, from time to time, a new AWS provider gets released, a new major version gets released, and they are breaking changes with each major release. So I looked it up, a large list of properties or parts of resources that have been changed that introduce breaking changes, for example, when going from 4 to 5 with the AWS provider. And now the problem is that if you import the provider just by saying, I want to have a version larger than, I don't know, for example, 4.0, then when AWS when the HashiCorp releases the provider 5.0, it's possible that Terraform will then just pick up the new version, which is 5.0, and you get all those breaking changes you on. And that's what happened to me. So I was using the Terraform AWS VPC provider, and then of course I was using Terraform. It switched from 4.something to 5.something, and I got a breaking change because of, I don't know, EC2 Classic was deprecated, and they removed it from their AWS provider, and then just my Terraform code was not working anymore. So this was frustrating, because then first of all, I had to find the reason for that. This was not too simple, actually, because it took me a while to figure out what happened here. And I think, this is something, if you write Terraform modules especially, or even if you just write Terraform code, I think you should be aware of that. And I think the one solution that I currently think of, that when you specify the Terraform version, you should not only specify the lower limit of the version. So let's say I want something greater than 4.0, but you should also say, and less than, I don't know, the next major version, 5.0, for example, to make sure that you not automatically get the new major release, because that will eventually break your Terraform stuff. So I think that is an important lesson I learned with Terraform. And then the next thing is I thought, oh, maybe you can use those Terraform log files. So Terraform creates those log files when you run Terraform. I think when you run Terraform init, it creates the log file. And I thought maybe this includes the AWS provider or modules or something like that, but that's not the case. So it only includes, I think, the Terraform version, if I remember correctly. Yeah. So I think it is important to specify this provider version more strictly. Or if someone else has another idea how to overcome this issue, I'd be happy to hear about that. But that's what I learned so far.
Yeah, so that's a good thing to keep in mind. And I think, Andreas, there's one solution that also works. And there is, I don't know how this operator is actually called. It's using the tilde and greater
because
than
that is not
sign. And I think this kind of does what you do without, if you say 4.0 with the tilde greater than sign, then
that's a good idea.
Exactly what you have in mind.
Of course, yeah, that's possible to do. Yeah, that's a good idea. But then, then it's important to use that, and maybe I have to make the maintainer of the Terraform VPC module aware of that this is an issue with the current module. Very good. Yeah, Michael, thanks for bringing that up.
Yeah, I mean, I don't know if there are any other implications that could kind of have any side effects. I don't know. So maybe there's a reason for how they do it. But
I like that,
Michael. That could be one option. Yeah. Okay, and I think the notation is very. I don't think that it is used anywhere else. So I think Node.js, the npm has its own syntax for that, but it's kind of, I think it's kind of custom for Terraform. But maybe I'm wrong. Yeah. So one last thing, Andreas. Before I dive into that, what I want to kind of spoiler already is that you are working on a new product, right? So that's probably what we talk about in the next show. You are working on a product to lower your GitHub Actions bill. So if you pay a lot of money to GitHub for running the workers, then this could be a good fit for you. So I'm very looking forward to that. So I think you learned a lot building that product, so you can share some details with us. And also I worked on something interesting for bucketAV. Basically, we are adding scan on access capabilities using S3 object lambda functions. And I will share my learnings on that in the last show as well. So we have a couple of exciting things going on at the moment, but we are kind of running out of time this time, so we just kind of move it into the next show. So Andreas, the last thing that I want to mention is that you have been invited to talk in Corey Quinn's podcast called Screaming in the Cloud. So I think most of you know Corey Quinn, so he runs the Last Week in AWS newsletter for, I don't know for how long, so like a couple of years. So he's very persistent in doing that. So every week you receive an email from him. So that's very cool. He summarizes what's going on in the AWS ecosystem. And you have been invited to talk to him about the new book and a couple of other things. So I will share the link to the episode with our listeners. And maybe while I do that, you can kind of summarize Michael, your conversation.
I think we mainly talked about writing the 3rd edition of AWS in Action. And besides that, covered also our journey from consulting business to a product development. So if you're interested in a little bit about the background story, what we have been working on in the past few years, and about AWS in Action, then this is definitely a great show. Okay, Michael, I'd say, that's it. We'll be back soon.
That's it.
Subscribe to our newsletter, the podcast, or the YouTube channel to make sure you not miss the upcoming show. Also, we're looking forward to your feedback. hello@cloudonaut.io, or find us on LinkedIn, Mastodon, or Twitter. You'll find all the links in the show notes or video description. So thanks a lot for your attention. Bye.
Bye.